Welcome back to our exploration of the Orion's Our Universe project. I'm your host, the MIUI author. In a previous video of ours, Gabby told you about the geology of chlorine planets. Now, I'll talk about their environments and how life has adapted to them. First off, why are they even called chlorine planets? No, they're not literally made out of pure chlorine. In fact, they are very similar in composition to Earth. The oceans of chlorine planets are mostly water, and the atmospheres of chlorine planets are mostly oxygen and nitrogen. However, chlorine planets have one small distinguishing factor, which gives them their namesake. They have a small fraction of hypochlorous acid and hydrochloric acid in their oceans, as well as chlorine gas in their atmospheres. But how many effects could such a seemingly small detail have? As you will see, a lot. First, how are the atmospheres on chlorine planets? The atmospheres of chlorine worlds are yellowish-green from chlorine and chlorocarbons. This leads to light on the surface being greenish and dim. There may also be organisms in the atmospheres causing haze, especially on worlds with thick atmospheres. These could be spores or floating mats of vegetation lifted using sacs of light gases, or many insect-like creatures. Chlorine gas is mostly found over dry regions, as in wetter regions it reacts with water to form hydrochloric and hypochlorous acid. Photosynthesis on Earth uses water and carbon dioxide to create organic compounds, and oxygen gas is a byproduct. Since there is plenty of water on chlorine planets, photosynthetic organisms on chlorine planets use this method as well. However, they also have another method that utilizes the abundant hydrochloric acid. They can use hydrochloric acid instead of water, which creates chlorine gas as a byproduct along with some oxygen gas. The combination of pigments that can photosynthesize both oxygen and chlorine gas is normally purple-black. Respiration is just the reverse of photosynthesis and can use chlorine gas in the same way oxygen gas is used on Earth. So on chlorine worlds, organisms can often respire both oxygen and chlorine gas. The atmosphere also contains chlorocarbons such as carbon tetrachloride, chloroform, and chloromethane. They are strong greenhouse gases which allow chlorine worlds to be situated further from their star than typical aquagine worlds or worlds with liquid water oceans. This greenhouse effect also makes chlorine worlds generally warmer, with daytime temperatures ranging from 30 to 50 degrees Celsius. Chlorocarbons also react with ozone, preventing the formation of an ozone layer and allowing harmful UV light to reach the surface of the planet. Because of this, chlorine worlds are more often found around M and K-type stars, as these emit less UV light. Organisms also often hide underwater in oceans and swamps to avoid UV light. This is not that restrictive, since most chlorine worlds are dominated by shallow seas and swamps. Due to being so common, chlorocarbons are often used in biological processes. Organisms use them as protection against extreme concentrations of water or hydrochloric acid, which are harmful. Many plant-like organisms have waxy coatings on their leaves made out of organochlorine polymers. Animal-like organisms have similar coatings and can even become dormant if conditions get too bad. Clouds on chlorine worlds are made out of water and hydrogen chloride. Hydrochloric acid evaporates easier than water, but freezes less often. Because of this, there is often more rain and less snow. Even extremely cold bodies of liquid rarely freeze, and when they do, the water freezes first, concentrating the acid, as well as dissolved salt. The oceans on chlorine worlds have lots of salts, since chlorine worlds have lots of heavier metals. Why do they have lots of heavier metals? This is because in order for chlorine worlds to have so much chlorine, they must have formed in a system that had higher concentrations of heavier elements in general. Because there are so many heavy metals, organisms from chlorine worlds are immune to their negative effects and even utilize them in their biology, in pigments, and in enzymes. Because of the high acidity on chlorine worlds, calcium carbonate is not deposited on ocean beds as it quickly dissolves away, and other carbonate compounds are deposited instead. The lack of calcium carbonate available means organisms make their shells out of more resistant materials such as scapolite, gold, and carbon. Since carbon is not deposited as calcium carbonate, it is instead deposited as more resistant carbonate compounds, as well as a high amount of organic sediments such as oil and coal. Chlorine worlds typically have higher gravity than Earth. This is because they typically are around as massive or more massive than Earth. This is because in order to have high concentrations of chlorine, they must have formed in a system with a higher concentration of heavier elements, and therefore more solid material to form rocky planets. Because of this, trees do not typically get that high unless they have massive structural supports or buoys using sacs of light gases, which can lead to the evolution of extensive airborne life. But due to the high gravity, large flying life forms are also rare. Life on all chlorine worlds is related, as it all originates from the mysterious chlorine biosphere-seeding civilization known as the halogenics, and so shares the same genetic code. This genetic code is carried by a double-stranded molecule that is very similar to DNA on Earth. But despite sharing the same basic genetic code, multicellular forms vary widely from planet to planet. And this is probably due to the halogenics designing different forms for each planet and the natural effects of hundreds of millions of years of evolution. By the way, they're called the halogenics, but they aren't known to have created biospheres with significant concentrations of other halogens, only chlorine. So maybe they should really be called the Ermurians. Or maybe they're just the Jacks, but that's something for another day. Anyways, where can you find chlorine worlds? Most of them and the systems they are in are owned by the caretaker gods, which is fitting for the caretakers, because if you know anything about them, you would know their goal is to protect life-bearing planets from disturbance. Systems with chlorine worlds are often left uncolonized in anticipation of the caretakers, who may even remove colonists by force if necessary. Some famous chlorine worlds include Daedalus, Outland, Vert, Dorine, Chorus, and Chorus's moon Solo. Daedalus and Outland were the first chlorine planets discovered. They were over 1,000 light years apart, yet shared almost identical life forms, which led to the idea of the existence of the aforementioned halogenics. Vert is home to the Canesians, highly intelligent, pre-sophic, eusocial creatures, as well as an advanced ecosystem. Dorine is famous for once hosting a xenosophan species, which is now extinct. And Chorus is famous for being the home of the Jade Chime Singers, a clade of cute musical provolves. There are so many interesting things about Canesians, Dorine, Chorus, and the Jade Chime Singers that they could get their own videos. Anyways, that's chlorine biochemistry. If you want to visit a chlorine world, they can be very interesting and intense destinations. Make sure to be protected from the heat, acidity, earthquakes, and atmosphere. Diamondoid objects may degrade, and certain nanotech may not work. You may be able to get specialized nanotech that works on chlorine planets. If you plan to visit a chlorine planet, have fun on your trip and stay safe. Make sure to follow all the necessary safety guidelines. Use code HAL17 to get 20% off your next visit to a chlorine planet. Like the video if you are a fan of halogens, and comment down below which halogen gas you'd like to inhale. Subscribe to learn more about fun destinations in a way, and join us next time when we talk about what the moon can't talk about. Goodbye, explorers.